we left off on, and if for some reason we finish the packet, then I'll leave it up to you guys. If there's any one in particular, like maybe you went home and you worked on some of these, and if there's any that I didn't do for you that you would want me to do, then I'll go do those. But I just want to try to give you some variety still. So let's actually skip to number 22. Because I don't believe, for the sake of it, we did one yesterday that was monthly. We're still dealing with compound interest. For this one, how long is the interest going to compound here? It's going to be 40 years, so we're going to be looking at the amount after 40 years is equal to, what's the principal amount? 100 times 1 plus 6% interest, so that's 0.06 over, what's the key number for monthly compounded interest? 12, because there's 12 months in a year, and that's to the power of 12 times the amount of years, which is 40. Really what that's telling you is how many times the interest is going to compound. If the interest compounds 12 times every year for 40 years, that the interest is going to compound 480 times. Let me see how bad this decimal would be. I hate asking you guys to put too much into a calculator. It's not too bad. So let's actually simplify this one. So in the calculator, you can put 100 times 1.005 to the power of 480. If you're not sure how I got any of those numbers, let me know. So 1.005 power 480 times 100. 40 years is a long time, but yeah, they made a nice chunk of change here. I'm getting the amount after 40 years, $1,095.75 approximately. Shelby, you got something different? Ingrid, any questions? You're gonna do well on the test tomorrow? Blink once for yes, and twice for no. Any other questions on this page? All right, let's go to the second to last page. Half-life. Hi, Antoine. Remember that all the formulas are here if you need them. The half-life is just like a decay formula, but the difference is the decay factors are always going to be the same. You still put a starting amount, then the decay factor is always going to be 0.5, or you can put 1/2. Either one is the same. And then it's just the time, the total time, divided by how long it takes for a half-life. That tells you how many half-lives there's going to be. So let's see. The half-life of a radioactive element is defined as we already know that. Radioactive carbon-14 is found in all living organisms and has a half-life of 5,730 years. Consider a living organism with an original concentration of carbon-14 of 100 grams. If the organism lived 5,730 years ago, what is the concentration of the carbon-14 today? Okay. So, okay, just use the name for amount. The amount is equal to, what's the original? 100 grams. That was the original concentration. Time is always 0.5. Probably easier. I think when I did this the first time, I kept on putting 1/2, but we can put 0.5. It makes it more calculator friendly. And the amount of time from 5,730 years ago until now is 5,730 years. And the half-life also happens to be 5,730 years. That means it lived 1 half-life. You have undergone 1 half-life. So 100 times 0.5 to the first power should be 50. What's the unit? Yeah, we're measuring this in grams. If the test asks you tomorrow to write a unit, you have to know what unit. If the organism lived 11,460 years ago, determine the concentration today. Okay, so the amount is still 100. It's still a half-life. The difference is now it's 11,460 divided by 5730. That looks to me like it just be 2 half-lives. Especially now that we understand geometric sequences. Like even if you didn't have a calculator, if you knew that one half-life yielded you 50, right? You went from 100 to 50. One more half-life would yield you how much? Next one, a radioactive substance has a half-life of 32. The starting amount is 70 grams. How much would remain after 128.5? 128 divided by 32. Is that 4? 4 half-lives? The fourth. Just put that in the calculator. 70 times 0.5 power 4. Questions? Are you ready for the test tomorrow? You're going to study a lot today? Cobalt, which is an element that's used to make alloys, has several isotopes. One of those, cobalt 60, is radioactive and has a half-life of 5.7 years. Just be careful on these for the units. Make sure that like if they're talking about time, that they're giving you both both in years or both in months. So this 5.7 years, and then how much is left after 57 years? So the amount is equal to the original is 80. Always times 0.5 is the half-life, and then 57 divided by 5.7 is 10. If you're really advanced and just put the 10, I can live with it. So 80 times 0.5 power 10. Does anybody here not know where the power button is on their calculator? It depends on the brand. Some calculators say X to the Y, some say Y to the X. The calculators that I hand out to people that don't have, it's an up arrow. It looks like that, kind of like it does on a keyboard. When you guys hit Shift 6, that little up arrow thing.
How would you put a takes like
Well, you have a couple options. If you were to put a fraction, you could put parentheses, like you said, 2 sevens. You could put like 2 divided by 7 like that, and it would know, it would just give you the decimal equivalent. Or, these do have fraction buttons, but you have to know how to use them. It has like an A, B, C button like that. That's the fraction bar. But if you don't know how to use it, I'll just tell you to use it. We'll see if they're going to give us decimals anyways. Oh, no, let's see. I have the answer to it. I'm getting that after 57 years, there would be, actually, this is exact. This is not rounded. This is exact. 0.078025. I wouldn't hold it against you. I just have, maybe it's my OCD, like I just have this thing where if it doesn't tell me to round, I do everything possible not to round. The only times I kind of feel forced into rounding is when it takes up my whole screen, because then I don't know the calculator might be rounding. When it takes up all the digits on the calculator screen, it could be that it's rounding and I don't know, so I'll just round. But if you were to put like 0.078, the only times I really hold rounding against you is if it specifically says like, oh, round to the hundreds, but then you round to the tens or something, or you round to the whole. Like if you, and in that case, you wouldn't lose the whole credit, just be like partial. Do I need to do another half-life, or are we, the hours? Are we good with half-life, or do you want to do the last half-life one? Or do you want to move on to sequences? Okay, and it says sequences, so let's do sequences. A virus reproduces by dividing into two. And after a certain growth period, it divides into two again. As the virus continues to reproduce, it will continue to divide into two. How many viruses will be in the system, starting with a single virus after 10 divisions? Write out a sequence using blanks where appropriate. Fill in the first 3 terms. Okay. I still don't know what it means using blanks where appropriate. So here, the amount of virus depends on how many divisions there's been. So after the first division, how many viruses are there? 2. So I would go like this. I would say that is 2. If I wanted to use it like because the first virus was there before any division occurred, so that would count as like my 0 one, if I wanted to do it that way. So then it splits, and then it splits. So now write an explicit formula for the sequence. Okay, so the amount of virus after the number of splits is equal to. If you want to use 1, let's see if you learned anything from, because you did the same thing yesterday at the beginning. If you want to use 1 as your original amount, how would you compensate? What would be kind of the trade-off you would do if you want to use that 1? There wouldn't be a -1, correct. On the exponent, you would not put a -1. If you want to put what's after, see, this is before the division occurred. But if you want to go after the division occurred, and use the 2 as your original amount, then that's fine. You could use 2 as your first amount, but then you'd have to put n-1 as the exponent. So n, you're in control. What do you want to use as the first amount? You want to use 1? Okay, so if you were to use 1, well, if you're going to use 1, you don't even need it, because 1 times anything is itself. What is the growth rate? Or the growth factor, I'm sorry. It's just 2. And then it would be to the power of n. That's just the formula. That's just a general formula where I could put anything in. And look, and if you ever want to check because explicit formulas can be substituted into. If you ever want to check if it worked, we'll plug in numbers. What is 2 to the 3rd power? 8. So what? If I were to keep on going, 2 to the 4th would be 16, like that. How many viruses will be in the system with us? Starting with a single virus after 10 divisions. Okay, so then that would be a sub 10, which is equal to 2 to the 10, which is equal to 10 to the 10. It will be 1,024 viruses. You look sad, man. The Hawks lost yesterday? Suppose you drop a 10. I feel like we did this exact same one yesterday. Was this at the end of the, and it was this exact same one where was it dropping from a different amount of feet? It was 15 feet instead of 20? Okay. So you drop a tennis ball from 20 feet after the ball hit the floor, it rebounds to 80. And it was the same 85%, right? Wasn't it the same 85% yesterday? So write an explicit formula. Well, see, the thing is, I would assume most of us are going to use this 20 as the original amount because that's what we read. We read 20, so we want to use 20 as the original amount. But what does the height of the ball depend on? in most problems that we've done, like in 90-something% of the problems we've done, whatever we're measuring depends on time usually. We're usually counting time in hours, minutes, months, whatever the case may be, years. But in this case, time is not a factor. What does the height of the ball depend on? The number of bounces, depending on how many bounces have occurred. So that ball is at 20 feet after how many bounces have occurred? None. So this is before any bounces. So assuming that you're going to use this 20 as the original, the 85 would have to be the common ratio, the 0.85. But then if you're going to use the 20, you would just put n as the exponent. If you're going to use n minus 1, then you'd have to put your original amount as however high it would be after the first bounce. What's 20 times 0.85? Is that like 17? I believe it's 17. You'd have to use 17 as your first amount. Caleb, no! Don't do it. You're hurting my feelings. Sticks and stones may break my bones, but you putting your head down hurts the most. How high will the ball rebound after the third bounce? Okay, well now that we have a formula, you can plug it in. Watch here. Let's do a little science experiment. Ready? Here's what I want. Just to show you that it works, I want to plug a 3 into the one that I already wrote, and I want to plug a 3 into, if you would have put that 17 that I told you as your original amount, 5 to the power of 3 minus 1, which is just 2. I want you to put both of those into your calculator and tell me what you get. It should be the exact same thing. And it says round to the nearest 10th. See, and see on this one where it tells you where to round. Now we can hold you more accountable. So the amount after 3 bounces, the height should be measuring height in feet, 12.3. Did you guys put both of those in the calculator? If you have a calculator, if I has a phone. Any questions there? Okay, determine if the sequence is geometric, and if it is, find the common ratio. So because it's saying to determine, we do not know if it's geometric. So we have to test every combo that we see. So we got to test these two, these two, these two. What is negative 8 divided by 2? Negative 4. What's 32 divided by negative 8? What is negative 128 divided by 32? Do we have a common ratio? So this is geometric. The common ratio is multiplying by negative 4. But wait, what do you mean by x? Okay, let's look at these again. We're not sure. They're asking us. They're not telling us. Negative 20 divided by 4 is 5. Negative 100 divided by negative 20 is 5. Negative 500 divided by negative 100 is 5. So is that geometric? And Caleb, what's the common ratio? Caleb, that's a 5, not an x. My essence. 5. Yeah, are you okay? Those are binoculars. I see you. Okay. From negative 3 to negative 9 is times 3. This is times 3. This is times 3. So this is yes. The common ratio of 3. So it looks like all of these are going to be yes. You're a no. This is yes. This is negative 5. Yeah, yes. With a negative s. Just kidding. It's not an s. It's a 5. Alright, for these next two, like they should have given us a lot more space for this. But notice how it says find the first 5 terms. So what they mean by this is take turns plugging in for n a 1, a 2, a 3, a 4, and a 5. I don't have enough space for that, so I guess it's not, well, at least it's first one, so I can do it pretty fast. A sub 1 is going to be what? If I plug in a 1, what's 1 minus 1? Anything to the 0 power is? Now, really, even though they are giving you an explicit formula, because the terms they want you to find are consecutive, it might even behoove you just to find it recursively instead of explicitly. Explicitly implies that you're substituting each time, which is fine. Nothing wrong with it. Plug in a 2 now. A sub 2. 2 minus 1 is 1, and what's 6 to the first? It's 6, right? It's not a big deal. You can do it explicitly, but to do it recursively would just mean, hey, what's the common ratio? 6. Just get each new number multiplied times 6. So you started with a 1. 1 times 6 is 6. Then the third number, 6 times 6, is going to be 36. The fourth number, 36 times 6 is 216. And then the fifth number, 216 times 6 is, don't tell me. 1296? Take that, math. But that could have also been done. That also could have been done explicitly by taking turns, plugging in 1, 2, 3, 4, and 5. You know,
Did you do a recursive function?
Yeah, there's more than one way. Any time that they want you to find numbers that are back to back to back to back, yeah, do it recursively. You know, unless they're like, oh, you know, what are the 47th, 48th, and 49th? Well, yeah, like the first one you're gonna want to find for sure explicitly because you don't want to have to multiply 47 different times. But once you find one of them, as long as you know the common ratio. Here, the more important question here is, here's an explicit formula, number 35. Which one of those numbers represents the common ratio? Huh? 3, good. Here's a better question. What word can be used to describe the explicit formula of a geometric sequence? What word can be used to describe? What adjective can be used to describe that? It's been the common theme of the last 2 units. Not linear. Linear is for arithmetic. Exponential, very good. Take that and yeah, exponential. So first 5 terms. Okay, so let's find the first one that's explicitly. If I plug in a 1, what's 1 minus 1? 0. What's anything to the 0 power? No, it's 1. What's negative 2 times 1? Or you could have said, hey, Mr. Romero, why'd you take me through all that? Didn't the initial amount up in front anyways? And I would have said yes. So now that I know that the first number is negative 2, really, well, I can just now multiply times 3 because that's the common ratio and get negative 6, and then get negative 18, and then get negative 54, and then get negative what? Each time multiplied by 3. Read, that's completely sad faces. Can you tell Anne what you're confused with and then Anne translate? She doesn't understand anything. Okay, well, just tell her that geometric sequences that to get from one number to the next, you're either multiplying or dividing. And how about this? If I can wrap this up like maybe 10 minutes early, do you think you can help her just like one-on-one? Would that be okay? It shouldn't take that much longer. Find the explicit formula for the second time in the last 30 seconds. What word can be used to describe the explicit formula of a geometric sequence? Exponential. So all we're doing right is writing an exponential function. A sub n is equal to, what's the first thing that comes after the equal sign? The first number, good. And what's the first number on 36? 4. Times, what comes next? The common ratio. What's the common ratio? Here they're telling you, so, well, actually, they don't actually tell you it's geometric, but it's safe to assume that it is going to be geometric. So, the common ratio here is -2. Let me do parentheses. So -2 to the power of. Well, since this is not a word problem, so like it's not like 4 is not the number that comes before the first number. 4 is the first number. So on all these, you're gonna write n-1. And if you're ever not sure, test it. Look, hey, Nakai, what's the third number you see up there? No, the third number you see on number 36. What's the third? 16, right? So check it out. If you're not sure if you got the formula right, okay, plug in a 3. It better give you 16. So like, let's say you would have only put an n there. Oh man, I messed up. I only put an n. Well, -2 to the third power is -8 times 4. Oops, that's -32. That's not correct. Whereas if I put in here an n-1, 3 minus 1 is 2. What's -2 squared? +4 times 4 is 16. How it works. You can always test it out if you want to be sure. She's looking at you and she's like, no, I don't understand. Here, read. Let's try number 37 with you. A sub n is equal to. What's the first number you see? 3. So put a 3. Times. To get from one number to the next, what are you multiplying by each time? It happens to also be 3. So put a 3. Another way to describe it, you see how here on these, they're giving us the set of numbers, and then we're writing the explicit formula. On the 2 that came right before this, it was just backwards. They gave us the formula, and then we came up with the first group of numbers. The only difference, now we're just going backwards. Here, a sub n is equal to, what's the first number you see? -3. What's the common ratio here? -5. To go from one number to the next, we're multiplying by -5 every time. The power of. A sub n is equal to, what's the first number you see on 39? Say it again. First number? -3. What's the common ratio here? Not 2. Close. -2. Power of -1. So now if I were to ask you, hey, Nakai, on number 39, what would the 50th number be? What could you do? Yeah, plug in 50. You can plug into explicit formulas. You can't plug into recursive, which is coming next. I'm not sure how other teachers teach the kids how to write recursive formulas. I'm just going to hold you to the standard that I did. All right, which is the way I always remember recursive is to split it up into 2 different, instead of giving you everything in one equation, you split it up into 2. So a recursive, you're going to write a sub 1 is equal to, what's the first number? -3. And then you would write and a sub n, which that's just, think of it like a language, the same way like that n is translating English into Vietnamese. Okay, here we're just translating 6 symbols, like math symbols into words. So a sub n means any number that's going to come out. It could be any number in the sequence. Is equal to this notation, a to the n sub 1. Don't think of it as an exponent. It actually goes underneath. It's just saying that just means the number that came before it. So every number that is to come is the number that came before it times, because on geometric sequences we're always multiplying. What are you multiplying by there? No, not negative 3. Positive 3. Yeah, there you're multiplying times positive 3. Here, this next one, just split it up into 2. A sub 1 is, what's the first number? Negative 2. And every new number that is to come after that negative 2 will be, because you took the number before it, that's not a power, that's called a subscript, it just goes underneath. The number that came before it times what? Negative 6. That's just a recursive definition. You cannot plug in, if I were to ask, hey Decay, find the 50th number here recursively, he can't plug in a 50 for any of these ends. He would have to multiply by negative 6 50 times to get the 50th number. Or he can use this to write one of these. Because I don't see any of those problems, but like, look, let's say theoretically they gave you, I don't even need to say theoretically because we have done it. The same way up here that we got these numbers and wrote explicit, you can do the same thing with these. You just need the first amount in the common ratio. Can you test these out here? Recursive? Oh yeah, okay. Start off at negative 2. What's negative 2 times negative 6? 12. What's 12 times negative 6? Negative 72. What's negative 72 times negative 6? Just going one by one. Here, a sub 1 is, and then every number that is to come after is equal to the number that came before it times. Yeah, this one also happens to be negative 6. A sub 1 is equal to 4. And every number that comes after is equal to the number that came before it times 5. 5 is the common ratio. Okay, the last two. Find the term that's named. Here, what term do they want you to find? Huh? They want you to find the 9th number. It does not state which way to find it. It does not say to find it explicitly or recursively. So if you wanted to do it recursively and you thought you had the time, 9 is not too bad. It's not the same thing as saying, like, find the 95th number. That would be a little more of a pain in the butt. But if you were to find it recursively, what is the common ratio? Huh? 2. So right now we have 4 numbers. So if you multiply by 2 one more time, that would give you, the 5th number. Multiply again, that will give you the 6th number, the 7th number, the 8th number, and then the 9th number. Every time times 2, times 2, times 2, times 2, times 2. It's not my favorite thing. That's not the way I'm going to do it, but it gets you to the same place. What I prefer to do, because now if they do tell you to find the 95th number, is to let's start off by writing the explicit definition, because that one we can substitute into. On an explicit definition, what comes right after the equal sign? What comes right after the equal sign on an explicit definition? What comes right after the equal sign, Kiara? How dare you? What comes after the equal sign on an explicit definition? Somebody not named Ann. Brian, do you know? Which the first number? Thank you. So that's negative 4. times, what is the common ratio here? What is our common ratio? This is positive 2 to the power of n minus 1. When you're not told otherwise, we assume that this first number is n. So now to find a sub 9, all I have to do is plug in a 9 for n. So a sub 9 is equal to negative 4 times 2. A sub 9 is equal to, ready, set, calculate. Negative 4 times 2 power 8. I'm getting negative 1024. Anyone dispute that? That would be the 9th number. Here, let's do this. Why don't you guys find the 11th number? You haven't done it yet. Raise your hand when you get it. You got it already, Decay? What'd you get? Yeah. Here, any number is the first number times the common ratio here happens to be 2 to the n minus 1. So the 11th number will just be 4 times 2 to the n minus 1. If you use your fingers and one toe, 11 minus 1 is 10. Just put that into the calculator. Are there any of these on the entire packet that I did not do that you would want me to go back and do? Because I have done at least one of every type that you could possibly see tomorrow. So if you were proactive and went home and worked on the packet. Nobody? All right, well, for the last 10 minutes, if you want to continue working on any of these on your own, you can. And if you get stuck, I'll be happy to help you.